Sagar Thakkar spoke about research outcomes on human milk oligosaccharides from the Nestlé research program Lactation for Infant Feeding Expertise, LIFE, during the NNI online symposium, which was scheduled at the 6th World Congress of Pediatric Gastroenterology, Hepatology and Nutrition. Breast milk is the optimal nutrition for infants and is associated with well-known short- and long-term health benefits for infants as well as for mothers. As technological advances take place, scientists are still gaining more insights into the human milk composition. LIFE, which stands for Lactation for Infant Feeding Expertise, is a program from Nestlé Research aiming to promote a better understanding of breast milk composition and its association with infant growth and development to develop advanced nutritional strategies for mothers and infants. Its research program includes 16 clinical studies in 20 countries, 8,000 breast milk samples from more than 2,000 women, multiple infant and maternal health parameters, more than 200 breast milk components characterized, and over 20 peer-reviewed publications and reviews, and more to come. What is known about HMOs in human milk? HMOs are the third most abundant solid components in human milk. More than 200 HMOs have been detected, approximately 160 HMOs identified, and 20 to 30 HMOs quantified. The LIFE team has quantified HMOs in 3,597 human milk samples from 8 prospective cohorts in 15 countries. Here are some examples of LIFE research on HMOs in human milk. 2FL and LNT are one of the most abundant HMOs. 2FL and other fucosylated HMOs are dependent on the FUT2 status. Levels of most HMOs decrease over lactation, except for 3SL and 3FL. Amongst term and preterm milk, no differences were found for most HMOs, except for 3SL and DSLNT when compared at equivalent postpartum age. Mode of delivery can affect levels of 2FL, 3SL, and 6GL. Maternal pre-pregnancy BMI can impact levels of 3SL and 6SL, whereas the number of pregnancies has no effect on HMOs. Association modelling from mother-infant cohort studies point towards a role of HMOs on infant growth. With this observational study, the objective was to evaluate the effect of different HMO profiles in the milk of secretor and non-secretor mothers on the growth and body composition of their babies during the first 4 months of life. Similar to a previous mother-infant cohort study, the different HMO levels in breast milk do not correlate or predict growth and body composition in healthy growing infants during the first 4 months of life. 2 recent studies from the LIFE team show a long-term effect of HMOs on cognitive functions. Early feeding of various mixes of HMOs improves cognitive functions in models of cognitive flexibility and memory up to young adult animals. The absence of the sialylated HMOs 3SL and 6SL during early life leads to impaired cognitive functions, specifically attention and spatial and working memory in adult mice. In conclusion, HMOs are the third most abundant solid components in human milk, with more than 200 HMOs detected and approximately 30 HMOs quantified. The drivers of HMOs in human milk are maternal genetics, stage of lactation, mode of delivery, term versus preterm birth, and pre-pregnancy BMI. HMO levels and mother's secretor status do not significantly correlate or predict growth and body composition of healthily growing and exclusively breastfed infants. However, HMOs have positive effects on cognitive functions,